While assessing the quality of your data, you may realize that some channels are very noisy during the entire recording, or that they show a good signal for only a small part of the recording. In this case, you want to remove the channel altogether from the participant or session dataset. If you click on Analysis, and then NIRx Data Preprocessing, and then Advanced, you can see here that there are two different methods available in Satori for channel rejection. The first is rejection based on a coefficient of variation threshold. The second is rejection based on scalp coupling index. Let's review each of these methods. The first criteria in whether or not to reject a channel in Satori is the coefficient of variation, or the CV threshold. Coefficient of variation is the ratio of the standard deviation to the mean of the signal in one channel and shows the extent of variability in relation to the mean of the time series in that channel. The higher the CV, the greater the dispersion, so the noisier the channel. In Satori, you can decide on a threshold above which a channel will be considered as too noisy and automatically rejected. You can do so here in the Channel Rejection panel by clicking on CV. The threshold is automatically set to 10%, meaning that channels will be rejected if the standard deviation of its time series is larger than 10% of the mean. You can change this threshold based on the specific needs of your datasets. For example, if your participants were moving during the experiment, you may want to use a larger threshold to avoid rejecting a majority of channels. On the other hand, you may want to use a lower, more conservative threshold if your data is very stable. Once you have decided on the threshold to use with your dataset, you need to keep it for all of your participants. It is crucial that all the recordings are pre-processed with the exact same method and parameters. The second criteria for whether or not to reject a channel in Satori is scalp coupling index, SCI. This method relies on the fact that when there is good contact between the skull and the optodes, one should clearly see a 1 Hz oscillation in the recording, corresponding to the participant's heartbeat. The scalp coupling index is an objective measure of how well the channel captures the participant's heartbeat, hence how well the optodes are coupled to the scalp. Scalp coupling index is calculated by filtering each wavelength signal between 0.5 and 2.5 Hz to retain only frequencies related to heartbeat. The two wavelength signals are then cross-correlated within each channel to check that the two oscillations are in phase, therefore measuring heartbeat coherently, which in turn provide evidence that both sources and detectors are in good contact with the scalp. Satori sets the threshold for SCI at 0.75. Meaning that channels with a cross-correlation between the two wavelength signals below 0.75 will be rejected. You can adjust the threshold of this parameter to higher, more conservative values if you have very good quality data, or lower, less conservative values if you wish to reject fewer channels. As for other pre-processing methods, once you've decided on a threshold value, you must apply it to all of your participants or sessions. Once you have set your parameter values, you can then click Go here to remove the channels from your dataset. Thank you for your attention.